So welcome to your video showing you a graphical construction cost cylinder method for the prismatic effects of decentration. So we'll start with step one, which is transpose your prescription into cost cylinder form. And for our graphical construction, we need to show where the powers run. So where we, in our cost cell form, we have axis. Therefore, we need to show where the power runs along. For axis, we use a cosh, which is at. So it's +4 at 120. And for our powers, run along 30, as power runs 90 degrees to axis. So our next step is we're going to use a full page and we're going to draw vertical and horizontal costs on our page. It's really important to get this as accurate as possible. So by using graph paper, we can get the horizontal and vertical lines exactly 90 degrees to one another. Then our next step is using a protractor. We're going to plot our power meridians onto the axis. So we're going to use standard notation. So to the right of the cross is 0. And we're measuring 30 degrees. As shown by our power meridians initially, we have a power along 30 and a power along 120. And for accuracy, we're going to measure it in the other direction also. Then using the ruler, we plot these lines together so they pass us through the centre of our cross, which in this case is our optical centre. So we also need to label the optical centre in the middle. We're going to mark with an O. We also need to label our principal meridians with their powers. So we have +4 running along 30. And we have +6 running along 120 degrees. Just so we remember that it's a right eye, we need to label the nasal edge of our diagram. And we generally indicate this with an N. As this is a right eye, our nose is to the right. So our next step is to plot the near visual point on the diagram. As shown by your question, this is 10 millimeters below and 4 millimeters in from the optical center. Now, if we were to draw that exactly, it would make a very difficult diagram to draw, so we're going to work to scale. So for every 1 millimeter, 1 centimeter. So we generally record that as a scale on our diagram as well. So in this case, we're going to draw a line 10 centimeters down and 4 centimeters in from the optical center. And to help inform us and finally our examiners, we will add the scale onto the diagram. So using the graph paper lines, run that 4 millimeters vertically and 10 millimeters horizontally until they meet on the diagram. And we're going to mark that R as our resultant decentration. And what's happening now is we're going to record our scale because we're going to need to use that when we're performing our calculations for the prism. So 1 centimeter equals 1 millimeter. So our next step is forming point R, which is our resultant decentration. Lines back to the principal meridians. So using a protractor or a ruler, however you prefer it. You might need to use a ruler there. The line coming from our resultant R needs to be exactly 90 degrees or perpendicular to our power meridian. Because we've got such a large diagram, the graph paper isn't going to help. So by using a protractor, we can make sure it's exactly 90 degrees. We can show where that intersects with our +4 line at 30. Then we do this exactly the same using the other principal meridian, drawing a point from R back to our +6 meridian. And then we can measure that distance. So we're going to measure from our O to the point at which the line intersects on our +4 meridian. So it's important to do this very accurately. So we can label this as C30. So C classes descent. We recorded this as 1.8 millimeters. What we actually measured was 1.8 centimeters, but because we're using our scale of 1 centimeter to 1 millimeter, our answer gives 1.8 millimeters. And we do the same with the +6 line. So we'll call this C120, just 10.7 millimeters once we've worked back to scale. Our next step is to calculate the prismatic effects along each meridian. We use this, so we perform this using Prentice's rule, which is P equals CF. P stands for prism, C is for the descent, and F is the power along that principal meridian. So for example, on the P30 line, our decentration we found to be 8 millimeters, and in Prentice's rule, we have to use centimeters, so therefore that is 0.8 centimeters. And the power along that meridian, the 30 meridian, is +4. So when we times these together, we get 0.72 base prism. For P120, using the decentration along this 120 meridian, we found as 1.07 centimeters or 10.7 millimeters, and the power is +6 diopters. And when we times those together, using our decentration in centimeters, we get 6.42 prism diopters. Now the next step is to decide the base direction associated with those prismatic effects. So we'll start with the P30 line. We place our pen on the point the line intersects with the meridian, as you can see. Now on a plus lens, the base is at the same position as the optical center. So using the pen method, you drop the tip of your pen towards the base on the lens. As we can see, it is up and in. It is in because the nose is to the right of our diagram, as it is a right eye. So when we're going to plot that back onto our diagram, we need to plot the base up and in from the optical center. We show you the same thing with the P120 line. So we place the tip of our pen where the line intersects with our 120 meridian. We're going to place the tip of our pen towards the base, which is at the optical center. And as you can see, we're going to draw our line up and out. So our base direction is up and out. So we now have to plot this prism back onto our diagram. So we'll start with the C130 line. We have a prismatic effect of 0.72. We measured that as 0.72. The same with our C120, our 120 meridian, we have a prismatic effect of 6.42 prism diopters. So we measure that as 6.42 centimeters. We then, the same as our first process, we need to draw a line perpendicular to the power meridians using our ruler until these lines intersect. We call that Z, and that is our resultant prismatic effect. What we actually need to find is the prismatic effect in the vertical meridian and the prismatic effect in the horizontal meridian. So to find the prismatic effect in the vertical meridian, we are going to draw a parallel line back to the original X at the cross axis that we made, the vertical and horizontal cross. So from our point Z, we use our ruler and the graph paper to measure a line from Z back vertically to the horizontal cross. And the same for our horizontal meridian. We measure a line from our Z out to the horizontal, the vertical cross, and we measure that line. And that horizontal line we've created will give us the horizontal prismatic effect. Now we need to consider the direction of the prism. So we ignore the previous method with the pen. When we are deciding on the prism direction, it is where Z is in relation to our original optical centre. So as you can see, Z is above the optical centre, therefore we have base up. And for horizontal, we can see that Z is out from our optical centre, because again it is the right eye. So because it is out from our optical centre, we class this as base out. And therefore we end up with 6 base up and 2.4 base out prism.